Assalamualaikum warahmatullahi wabarakatuh. Here is my presentation for my final project for the subject modeling in operations research. So the topic that I select for my project is the fundamental metrics and absorbing state analysis of customer payment behavior. So let's move on to the introductions. So basically, this study will be looking into the real data and real problem. We will look into the behavior and data from one of the multinational insurance company in Malaysia. So what the company would like to do is that they would like to improve their retentions ratio because as they realize after COVID strike, as much as the consumer are aware on the importance of insurance, but due to the affordability levels, it is not easy to sell the insurance to customer. Hence, there is a new strategy applied by the company where in this um, after COVID's period, they will be focusing more on saving the customer, improving the retentions, and also customer persistency, rather than acquiring a new customer. So with the new strategies and initiative, right, hopefully it should be able to improve the lapse rate and also cancellations rate. But with all the initiative that have been done by the company, it seems not enough, to them because they still see quite a significant increase in the number of lapse and cancellations every month. So what are the problem that we are faced here in the company? One, uh, when we go outside the normal thing that we do, looking into the collections rate, some things that has never been done before, going into looking deep dive analysis into the operational work, which is collections, right? Looking into the outstanding premium from the report derived from that activity, there is actually a constant increase in the outstanding premium volume every month. But we already know that despite all the existing strategies and initiatives that have been done, the lapse and cancellation still facing an increase every month after the COVID period. Then when like I mentioned, looking into the collection stage, right? Is something that we never explore. We never try to do something that's more proactive, before the customers start to say, yes, I want to cancel my product or start to stop paying their premium, right? So we never try to explore that area, looking into the collections stages, the time when we collect the customer. We never really, try to see the pattern, from that levels. So what we're trying to do here is that from this analysis, hopefully the finding should be we should be able to do something that is more proactive in improving the retentions of the company. Okay, I'm elaborating more on the problem statement. Like I mentioned, looking into the graph here, this is an actual data taken from the company monthly collections report. So you can see that from month to month, looking into June to October, there is a significant increase, a constant increase in the volume of outstanding premium. And as you can see, looking into the gap, the difference between the month by month movement, is getting bigger and bigger in terms of the difference, right? Um, it- this is the retentions interventions strategy that the company is having, right? If we plot against the lapse, the customer, the lapse sessions customer, the life cycle of the customer, who want a lapse when they first coming into the company, right? During the acquisition process. And after that, they start to have some kind of mispayment. They stop paying. And after they stop paying, after several months, the customer status will turn out to be lapse. So when the customer lapse, we will have this what we call it some kind of cancellation value cancellation rescue to save the customer. If the customer able to be saved, most of the time the customer will offer a new policy, or they will try to downgrade the value. And if we fail to save the customer will exit the company. Okay, so the area that we think is important for us to focus and can be very uh, beneficial if we're able to look into the customer mispayment, which is the stage or the process or the level that we never been explored before. Looking into this payment collections process, there are 7 steps, to run the collections process every month. So every month we have to the collections team have to prepare the list of customer. They will send to bank. Uh, they will do the charging, and then after that, those unsuccessful payment, they will return it to AIG for the company to do the checking. And for the successful payment, the team will update the status online. And for the unsuccessful payment, they will have to reprocess the list again and prepare it for the next cycle. So every month we will run this process for 4 cycles, and at the end of the month, the team will assign a status to each and every policy that we have in AIG. So talking about the status here, the policies the payment status, there are 4 status. One is active, second is 1 month mispayment, third is 2 month mispayment, and the last one is lapse. So active is referring to those customer, very good customer, they have no outstanding. 1 month mispayment is referring to customer with 1 month mispayment. 2 month mispayment referring to 2 month mispayment. And lapse, if the customer have more than 2 month mispayment, the status will change to lapse. So once the status change to lapse, of course they will go to cancellation rescue. But if you're not able to rescue them, hence the customer will leave the company forever. Right? Okay. So, from the understanding of the problems and everything, I think it is very important for us in this study. When we do this study, I would like to come out to understand these 4 things. My objective. One is what is the amount of premium that can be collected in future month. So here we would like to calculate how much premium is expected to receive in future month from the outstanding policy. If we have outstanding policy of 200,000, we would like to understand how much we can collect from the customer in future month. Second, we want to understand the transition between customer from outstanding to active. Same goes the transition from customer who have outstanding to lapse. So these are the 2 things that we are, trying to understand. And the third one, of course, the absorbing state. We want to calculate how long the customer will stay to have outstanding status before moving to another state. So from the analysis of the data from June to October 2022 that we extract from the billing system, we able to compute this diagram. Right, we observe the transition from month to month and try to see into the behavior, doing some analysis and understanding, and from there, this is the transition probability that can be defined in the state diagram. So when looking into the state space, I take the same policy payment status, which is the A, L, M1, and M2 as a state space. And in this analysis, my time step will be 1 month, since I want to know the movement of the policy from 1 month to another month. From the diagram, from the state diagram, we transform it to this transition metric. So this is the transitions metric that we able to compute from the data. So from the transitions metric, we can then calculate the fundamental metric. Before calculating the fundamental metrics, we have to partition the the transition metrics into this 4 partition, which is I, O, then I have Q and S. Then by using the formula, F equal to 1 minus S, and I'm able to compute the fundamental metric as stated there. So so this fundamental metric, after calculating the fundamental metric, we will then need to validate whether the value is correct or not. So again, when we want to do the validations, I'm comparing it against the actual data. Okay, if we're able to understand what is actually the fundamental metrics, so we know that fundamental metric from the fundamental metric, we're able to calculate the expected number of month customer will stay at state 1 month before absorbing. So by calculating the row sum, which is 1.1728 plus 0.2587 is equal to 1443, so it indicates that customer will stay at state 1M for 1.43 month before moving to another state. So trying to apply these situations or this some the situation back to the actual data, right? Since from the fundamental metric, we can conclude that the customer will stay at state 1M for 1.43 months before absorbing to another state. So then we will look into the data. We are referring to the month of June. So example, when the customer is having state 1M in the month of June, so there are 3,786 customers in state 1M for the month of June. When we look into July, we have only 399 customers who remain in the state. So it means that there are a total of 3,389 customers out of that 3,786 customers who has been absorbed to another state. So from there, we can calculate the percentage of policy that has been absorbed, which is 90%, which is high. Okay. And then B, looking into the state 2M, right? When we are trying to interpret the fundamental metric looking into the 2M state, trying to understand the expected number of month customer will stay at 2M state before getting absorbed. So the answer is that we can calculate from the fundamental metric is 2 months, meaning that whoever customer at 2 month state, it required them 2 months to stay in that state before absorbing to another state. Again, we're doing the same method, looking into the actual data, but this time, instead of comparing 1 month from just now, from June to July, we're comparing from June to August because we want to satisfy that 2 months finding, from the fundamental metrics. So when the customer who at the state of 2M in the month of June, which is 728, when we refer to the month of August, only 7 remain at the same state. So we have around 721 customers out of that 728 customers who are already absorbed to another state. So that sum up to 99% of customers who have 2M state in June will absorb to another state after 2 months. So in conclusion, what we can conclude here is that from the finding, since the percentage of customer from the actual data that satisfy the expected value calculated from the model is actually more than 9%, hence I can conclude that the expected number derived from the fundamental matrix is actually correct. So after validating the model and the model now is correct, next is to do a deep dive analysis, a drill down analysis to answer my objective. First, we would like to understand the expected total outstanding premium paid and total lapse. So let's just assume that the total outstanding for 1 month, for a particular month, this is actually derived from the data, but I'm taking a particular month here, is 462,000, and the total outstanding for customer who's having the 2 month outstanding payment is 43,650. We can calculate the expected total outstanding premium paid and also total lapse by calculating the MFQ matrix. So when I calculate the MFQ metric, which will further elaborate in my paper, I get 315,180, 80,166,000 for lapse. So from here, we can conclude that out of the 505,000 outstanding premium for that particular month, we able to collect. We expected to collect 315,180 payment, while another 80,000 will move to lapse. But then we have another remaining 110,000, which will remain, as outstanding. So here, looking into this, when we look into the 80,000, right? So that 80,000, when we divide by the total amount of outstanding, it is actually sum up to 15.85% of total loss. So let's just take it as a loss, that 80,186, or 80,166. If this condition is persistent, continue to happen every month. So it is expected for the company to have around 15.85% lost every month. So I'm taking this number to bring it into my next analysis, which is to analyze the impact on the persistency, taking into the consideration the expected value of outstanding premium that we derive from the fundamental metrics and also absorbing the observing states, right? I will then factor it back to the actual data, taking the percentage 15.85 times the amount of outstanding every month, then I'll get certain number. So from the number every month, for the month of the first, second, and third month, I will calculate the movement. For example, if month one is 10,000, month two is 20,000, I'll get the difference between month one and month two. So from there, should be able to understand the volume of increase or decrease that I will face every month. Because, to relate this into the persistency, right? What I'm trying to prove here is, if uh, the loss is increasing for that month. So in the month of June, we experience an increase in terms of the volume of loss. How will it impact the persistency? So this is what I'm trying to do here in this analysis. So the orange line here, so the number that I explained just now is explaining by the blue line, which I put as the expected loss movement. Movement mean the comparison between month two and month one, the percentage of movement, right? So that's how it looks like, the blue line. And the orange line is actually referring to the actual 6-month persistency of the company, right? So when we plot it together, looking into the same month, uh, there is, interestingly, when we look into the site, it's so interesting to know that these two number, the expected number from the fundamental metrics and also the actual persistency number, is highly correlated, right? Because what we can conclude here is that for any increase in the expected loss movement, if we have a significant increase in the expected loss, our persistency will drops. So here we can say that by using fundamental metric, the calculations of expected loss, it is actually can act as an early indicator to improve the persistency, because this is what happened first. The persistency will happen later, right? So like I mentioned, when the customer is at 1 month and 2 months, uh, their status is still active, then this analysis tells that by targeting the customer during that time, by sending something to that customer, when they when they transform into the 1 month outstanding or 2 month outstanding, you should be able to improve uh, the persistency significantly. So in conclusions, the benefit that are we able to contribute of and the contributions of the study is that the key finding that I'm able to conclude from this study: fundamental metrics and absorbing state analysis will act as an early indicator to trigger the company actions in order to improve customer persistency. As been explained in the previous slide, there is a very high correlations between the persistency and also the expected loss, the loss of the premium movement. Hence, I think that when we able to calculate the fundamental metric in observing state at the early stage, from that number, if the number is decreasing, if the number is increased, then maybe it will be the right time for the company to do a quick win campaign or interventions. And then by knowing the intervention windows from the fundamental metrics, right, we know that customer will stay in that state between 1 month and 2 months. So that will be our interventions window. We should able to know that if we want to do something, if we want to save the customer, it need to happen between that windows from 1 month to 2 months after the customer state move into that outstanding state. By calculating, and the next is discovering new premium strategy. Okay, since we should be able to calculate the loss and also the um, collected premium, from the fundamental metric and calculating the absorbing states, right? We can relate it back to the volumes, right? So when we relate to the volume, we can compute the average uh, number of policy of those customers who lost, right? If it's high, then maybe in the retention intervention, we would want to offer lower premium to customer in order to improve their persistency. Yeah, so that's all from me. Terima kasih. Assalamualaikum.